Est-ce que ça fonctionne? Good morning. So welcome to our presentation. So I'm Vlad Trifa. I'm Chief Product Officer at Ambrosis. Normally Angel is presenting with me, so he's been in something else because of the timing issue. I'll talk a little bit about the convergence of IoT and blockchain, how the two work together. And a subtitle for the presentation is how to remotely control alarms so you don't wait 2 hours to turn them off. That's a nice title. So, before talking about IoT, I just want to talk a bit about the starting point of our project, which is, you look at supply chains today, how stuff is moving around the world. You have lots of fraud, lots of problems, especially in the food or in pharmaceuticals. You have a lot of problems tracking where medicine comes from. There are lots of people dying every year because they are ingesting counterfeit medicine, which is not what it's supposed to be. So that's a big problem, and it seems to be even bigger and bigger every year for some reason. Although we live in a digital world and things should be better, the way we move stuff around the world becomes messier and messier. So our vision is really that combining IoT, so sensors, all sorts of devices to track physical goods as they move around the world, and blockchain can fix that, because when you have lots of companies shipping their products, you have suppliers, you have manufacturers, every step in how products get moved creates essentially an opportunity for someone to enter and do something bad in the system. And by digitalizing all this process, by monitoring with sensors, we can increase the security and especially the efficiency of how stuff moves. So IoT, I think there's a tsunami in the last few years. For 10 years we hear the word, but I think we see more and more devices getting connected to the internet, toothbrushes, all sorts of weird things for some reason get connected to the internet. So that's nice, but in fact there are still quite a few issues around IoT today that still haven't been solved, and that's been for over a decade now, which we kind of call the 3 S's. The first, and maybe the biggest one in IoT, is the notion of standards. So we have hundreds of standards out there. There's no universal standard for IoT, especially when you think large-scale IoT systems, not small setup, but really global type of systems where you need interoperability. That problem hasn't been solved. So it's really a bunch of intranets of things. The second issue is scalability. You're looking at large and large amounts of data. We're talking about billions of sensors being connected by 2020. That's like terabytes of data generating every hour, which need to be collected, which needs to be processed, stored, shared, and so on. That's the second issue. The third one, of course, is security. And I think I've been in the IoT space for 15 years now, I think, and the first question that people are asking when you talk about IoT is, well, what about security? And the answer is, oh, let's make it work and we fix the security parts later. Now you look at the consequences of that. You have your fridge being used to hack other systems. You have a bunch of problems around security in IoT because it was done in a very lightweight manner. And I think the third argument really here is that learning from IoT, from blockchain security can make those systems a lot more secure. So one of the first observations is essentially that blockchain kind of loves IoT, and there are lots of very interesting opportunities for making the IoT a lot more secure, a lot more efficient, and especially a lot more scalable. So I want to address a little bit how those 3 problems can be solved after each other. So at Ambrosis, what our project is really is to build a decentralized middleware, really a data transmission processing system for all sorts of sensors and applications to be interconnected to build really large-scale IoT applications. And the very important aspect is it needs to be decentralized. It needs to scale in a very efficient way. We really focus on supporting both private and public data because many of those IoT applications, especially industrial ones, they require data to be private, or at least very well secured, so not necessarily publicly accessible. We've been working on a universal data model, which I'll get to in a second, which is a higher level abstraction, because if you look at blockchain, it's essentially transactions, smart contract calls, wallets, but for IoT, you're talking about data streams, you're talking about applications and higher level constructions. We wanted to make sure that the fees for using such a system is stable, because if you are affected by volatility of cryptocurrencies, no industrial project or enterprise can really use that, because they have no way of predicting how much the system is going to cost. Pretty obvious. We really want everything we're building to be fully open source, so we have lots of things as well that are there, so it's kind of an open kitchen approach. And then that thing also needs to work based on crypto economics, so really a sound way of incentivizing the participants. So this is the overall stack. At the core of what we're building is essentially a core blockchain, which is regulated, kind of the brain, the logic in the entire system. On top of that, we've built a decentralized but incentivized storage layer, which works kind of like IPFS or Swarm, which is designed to store all those terabytes of data, sensor data that needs to be stored. The third layer is really all the APIs, gateways, because a lot of the applications and a lot of the traditional enterprise systems, for example in IoT, they are very much used to classic REST APIs, so it's really the whole developer stack. And on top of that, to develop a variety of dApps that can talk to sensors, that can process sensor data and such. Now let's address those three problems a little bit more in detail. So the first one is really the standard. So if you look at IoT today, that's essentially how it looks like. You have a bunch, hundreds, if not thousands of protocols. And when you're trying to build an IoT app that can control a few things in your house, for example, you need to learn about a bunch of those things. Like many of them are very, very obscure, like BACnet, and Ocean, X10, which is even older. Bluetooth maybe is the only one that people might be quite familiar with. Zigbee eventually, but there are like hundreds, and that makes it extremely difficult to build an application that integrates data across a variety of sensors and makes that all work together. So one of the solutions we've been working on is really what we call the Web of Things, because we say the Internet of Things, which is kind of low level, but what if we add a web layer on top of that? So it's really about using the same protocols that we use on the web today, so all HTTP, JSON, and everything that web developers are used with, and be able to interact with the physical world just by sending HTTP requests. So that's really what we've been working on for over 10 years, I think, as an idea, is really to build all that higher level. It does make perfect sense, because first and foremost, you can leverage everything that's out there for web services, caching, security. All of those things come for free, and you can suddenly start sending HTTP requests to lamps, to alarms, instead of turning them off. All those things would be very interesting. And TCP/IP Wi-Fi is pretty much ubiquitous, so it's less and less an issue today. HTTP as a protocol was really designed for large-scale, loosely coupled, decentralized systems. And I think when you look at the history of HTTP in the last 29, almost 30 years it's been around, you can see that even though the protocol has been evolving very, very little, the type of web applications we do today on top of HTTP has completely changed, although the core protocol at the core hasn't been evolving, which is very important, because that leads me to thinking that there's so much that was already built in HTTP, and most websites or most web services are using maybe 10% of the standard. And we've done a lot of research to show that you can actually use that pretty efficiently for streaming data from devices. The third reason is really you can integrate with the existing web ecosystem. So you can imagine suddenly integrating all sorts of physical stuff directly in web pages, or you can create JavaScript, lightweight client-side applications to control the physical world around us, which is really interesting. And finally, maybe the most exciting reason why using web technologies is it's extremely easy to learn for developers. You have like millions of people who can do JavaScript, who can learn very, very quickly, as opposed to the very obscure, sometimes proprietary protocols that are being used by devices. So all of that turned into what we did a few years ago, which is what we call the web thing model. So essentially, the idea here was to create a JSON representation, a data model. How do you describe devices? How do you describe the features of a lamp in a very much, it's almost in the standardization way, but without adding a lot of constraints, because if you look at many standards, they try to model the entire world, and that becomes so complex that no one uses them. What we tried to do here was to make one that is as simple as possible to build APIs for physical products in a very universal, interoperable way. So the model we've been using, and that's the one we also use on our project on Ambrosis, is essentially modeling everything in the real world. As you know, every time you want to track something in the physical world, an object. Here, for example, is a pharmaceutical kit where you can transport vaccines that need to be stored at a certain temperature. That becomes an object, a unique object. You can put a sensor in it, and that sensor will be linked to an asset. An asset is essentially a globally unique digital identity for a physical item that is stored, persisted on the blockchain, so you can make sure that no one is able to interact with an asset. That essentially comes down to what we call serialization. So if you look at the pharmaceutical industry, there are more and more regulations obliging every single box of medicine to have a unique identification number. And that's something you get as a side effect. In one single API request, you get serialization in a crypto-secure way. So if you have billions of products you want to track individually, you can create a billion assets right away. And then all the information you want to add about that asset, for example, when this bot was, when he was fixed, when he was transported, it wasn't really caught, it was manufactured, but anyway. So that's the idea, is you can do that through events. And events are pieces of data you attach to asset over time. Every event is timestamped, can have public or private data. You might have some events that the public needs to see because that's a public piece of information, just like you can have some very private data you want to attach about the product. For example, that the regulation requires you to store about your medicine, but the public shouldn't necessarily see. So all of that you can do in a very, very simple API layer on top with a very, very simple JSON data model. So now, the second problem when it comes about scalability, what we've been exploring is to do a layer 2 scalability via what we call gateways. So the way it works and what we've built, one of our components is essentially, we call it Hermes, and that's a REST API, a proxy between the blockchain and your traditional applications. So suddenly you can just use our API, very simple, a script, your app, whatever you want, sensors who send data to this API. All that data gets stored either locally, if it's private data for the events, and if it's public, then all that information gets put in what we call bundles. A bundle is a big chunk of data. It's a file that can have 100, 150 megabytes, and that bundle gets uploaded to the blockchain, where the proof of that data stays on the blockchain in a transaction, but then you have those additional layers, those additional data storage nodes, which get paid to store that file for you. And they kind of watch each other to ensure that no one is modifying historical data. So don't want to go too much into details, but happy to discuss that afterwards. So this is just the same way at scale. So the vision was that everyone can run the Hermes node. It's entirely open source right now. Anyone can download it. And you have like a tiny IoT cloud, if you want, on your laptop. You can connect your applications to, you can scale, you can modify, you can use whatever data storage you want. And what it will do is package all that information, upload that to the Apollos, which is the blockchain element itself, and the Apollo will coordinate the storage of the actual file of the entire 150 megabytes for that bundle and reward the different nodes that are storing it. So this is very interesting because we are not bound by the TPSs of a blockchain itself, because in one single transaction we put a bundle which has 20,000 sensor readings. So even if we don't have 100,000 TPS is on the blockchain, that's absolutely not an issue because we can record millions of data points per second anyway, which was very, very important for the IoT applications, where you just cannot be bound by the current limitations on blockchain. And there's very little reason actually to store all the data on chain as well. So that's the second element. The third one is really the security. So blockchain data is nice, but how do you trust the data in the first place? So that's been always the biggest issue in supply chains is, you know, yeah, on the paper, everything looks good, but you always have the human in the loop, which kind of opens a box, which adds additional counterfeit products. So it's really about controlling the physical flow of goods. How do you do that? How can you trust where goods are, how they're moving? So for that, we build our own sensor. We call that L1. But essentially, it's a very small sensor, again, open source. What's really interesting about it, it uses Bluetooth for communication, has temperature, humidity, shock, basic things. What's really important is we had to create our own custom sensor for that because we wanted it to be really controllable and programmable, and especially it has a crypto chip on it. So there's really a hardware security which signs every single data which is measured. So even though you have a mobile phone that downloads the data, you still have the actual signature for every single reading that came from the sensor. And that's already very different from pretty much 99% of the IoT today, which only uses encryption. But when you have encryption across several hubs, you kind of have to trust that in between no one is messing with your data. And you have no guarantee, no way today to prove that some sensor reading actually came from a device or was actually modified in between. And that's one of the key challenges we've been solving. So we have a lab in Switzerland where we explore the hardware, really the physical part that can be attached to products, to boxes. So maybe just the last point, I think what's really important is the tooling. So that's always been a challenge for blockchain, for IoT application, is it's not easy to build those things because you need a lot of components. You need to manage the identity of users, of devices. You need to process data. You need to integrate applications and systems together. And there's a lot of wheel reinvention, lots of people who redo the same things over and over. So we really, really tried to simplify the development process of combining both IoT and blockchain in one. We really try to focus on a developer platform, so all of that is documented on our website. We try to put all sorts of SDKs, obviously web SDKs for building web apps that exchange data with devices, native apps, native SDKs for native apps, iOS, Android for reading data from the sensors, for example. We're also building a bunch of embedded SDKs so that devices can talk directly to our nodes. And the key word here is fast prototyping, because a lot of the projects, even in blockchain, traditional blockchain, it takes a while to build just to have a first proof of concept. And I think that's especially true for non-blockchain developers. So when you look at big companies, they first want to understand the value of blockchain for them before investing substantial time to build a proper solution. They really want to prototype and understand. So we really focus on giving them the tools to identify the value of blockchain first, and once they understand, once they were able to build those apps and test and improve and refine them with clients, then they can take their own Hermes node, they can scale it, they suddenly become entirely in control of their data, and there's no more centralization. But the point I was trying to make is a SaaS can help a lot the development because you don't have to worry about setting up all those components. And that's something like infra, if you want, having a proxy such as infra to building your apps, created a bunch of ease for new developers to jump in and build stuff. So, just to conclude, I think what's really clear is that the IoT clouds you're seeing today, big companies having their IoT cloud, are just not going to work at scale. There's no way you can scale that to support all sorts of systems and devices efficiently. So the best trade-off to scale such systems for the future is a combination of more core blockchain, a public blockchain that different systems can plug on, but a lot of the scalability comes by having off-chain data, which is secured on the chain essentially, and a proof of that is working. working. So it's really a combination of easy APIs, distributed IoT clouds, if you want, that are all linked together with one single chain of truth. And this layer 2 this way really gives you the performance, the security you need for scaling those applications. Obviously, fixing the data integration has been and will remain a big challenge until we start standardizing how do I define the functionality of this projector, of the lamp, of the sound system in a truly interoperable way. Blockchain security, that's really interesting, and I think that should become the new default for any type of IoT application. So really using strong cryptography, not just encryption, but literally signing, hardware security, and such. To make all of that work at scale, you need as well a good crypto economic system that incentivizes participants to work and to check each other's work. And finally, you really want a good set of tooling, something that provides you all you need to build, scale, manage, and eventually monetize those applications. So thanks a lot for your time. If you have any questions, I don't know if we have time, but otherwise I'm around, I'll be around. We're very findable, so happy to hear from you. Thanks.